Welcome to deploy a Python web application from scratch on Linode part 2. This series picks up right from where we left off in part 1, so be sure to check out that series first. Now what we're going to be covering are a number of topics to make our application even better. That's going to be custom domains, automatic HTTPS, load balancing with Nginx, a PostgreSQL database server, both for production and development, on Linode, a Redis server, also on Linode. We're also going to learn how to actually validate data that's coming into our application so it's nice and clean and it doesn't cause disruptions on the database. That's pretty cool, I think. We're also going to be talking about how to actually test our code to ensure that it is valid and ready for production prior to pushing it into production. And then finally, we're going to bring everything together to make sure our Fast API or our Python web application is working well. Now, my name is Justin Mitchell. I'm going to be taking you through this step by step. And if you do have any questions, let us know in the comments. Myself or somebody on the Linode team will most likely be able to help you out with that. Now, I really want you to understand how to do these things from scratch so you're more resilient and more appreciative of changes that happen to automating all of this. I think infrastructure as code is one of the most fascinating topics you can go from here, but the general idea is that we need to know how these services run by themselves in a way that's scalable and sustainable. So let's go ahead and jump right in. Let's set up a PostgreSQL database. This, of course, is an open source database, so we can have our application being a little bit more dynamic. We can actually store data about our users and other kinds of things an application might need. And so where do we do this? Your intuition might be, oh, well, let's jump into our other Linode and install it there and just run it. And this is fine. This actually would work, technically speaking, but it brings a couple new challenges. One of those challenges has to do with traffic, right? So if you start to get a lot of traffic to your application and you also have your database on there, then this 1 gigabyte might actually not handle that load. So what we could do then is actually resize this image, right? We could make it bigger. We could go up to 2 gigs or 4, and that makes it quite a bit bigger for really not that much more. But of course, once it gets really big, then we're talking a lot, right? And so what we want to think about, though, is not just scaling it up, but also, practically speaking, bugs and services going down, right? So if we only have our application and database on one server, if the application goes down, there's a good chance that we cannot access the database. And then vice versa is also true. If the database goes down, the application might not be accessible either. So that's not ideal. That leaves us very vulnerable in two ways, right? So if there's any bugs or if any of our services go down on this server, the entire thing is basically down. Or we can just assume that the entire thing's down. The other side is the actual cost of vertically scaling. That is making this server bigger and bigger to handle load. So what we can do then, instead of vertically scaling by making this bigger, we can horizontally scale. That is making more instances of a server. Because if you think about it, $5 a month, well, I can have almost 200 servers for the price of this one right here. Literally 200. I mean, that's a lot. Granted, it's not going to be as powerful of an individual machine, but each individual service can actually have its own resources allocated correctly. Now, I don't think you're at the point where you're going to have to worry about that kind of scale just yet. But what we do need to worry about is if any of our services go down, we don't want all of the other ones to go down, right? So if I committed some bad code and that code was now my app server, right? So like as it stands right now, it's running, but what if I accidentally made an issue in Fast API and this came crumbling down? So there's a lot of ways to mitigate against that as well. But that whole time, we want to make sure our database server is there and running. And so let's go ahead and create an individual database server now. And we're going to do it in the same exact region as our other server, our application server. So we'll go ahead and create Linode. I'm going to stick with Debian and 10. You could choose whichever one you like, but using Debian means that a lot of the same commands here are going to be the same. And then we're going to do the Fremont region. I'm going to stick with the Linode. because it's only $5 a month. Plus I get that $100 credit. So that's good. Next, I'm actually going to label this one a proper label this time. So I'm going to go ahead and do Postgres SQL database server -1. That is just a little bit more of a robust label for this service, right? So now it's going to be a lot easier for me or anyone on my team to know exactly what's going on with this. And then maybe I even want to add in tags in here as well. Now, adding in tags would be really good for if you're doing this for a client or something like that, right? Like my business client 1 or freelance job, -ABC or something, right? Like it's really up to you on how you end up tagging these things, but to keep things organized, it's probably a good idea to tag them. Now we're going to go ahead and do a root password. I'm going to go ahead and suggest a strong one, and I'm going to literally copy this one. And I want to bring it into my VS Code here, just so I have it, right? Because in a moment, I actually want to SSH into it. And that's all we're going to do here is just make sure that this server is up and running, and then we will actually SSH in. And so if you remember back, what we did before was we actually logged in through SSH with this root password, but now I'm actually going to add in SSH keys. And so to do this, what we're going to do is we're going to list out everything at the location of ~/.ssh. Now, Mac, Linux, and Windows users should have this at this point with this kind of data. Now, if you're on a Windows, what you're going to do is something like this to actually see the key we need to use, which is .pub. This should give you the same value. If you're on Mac and Linux, you'll use cat instead, and it'll give you this. Naturally, you could always navigate to that directory and find what this data is. So I'm going to go ahead and copy this. This is our public SSH key, and I'm going to add it into here. Notice that it says SSH public key. This is the one that I can actually publish. It's okay. The other one, this one right here, we do not want to publish. Now, you also might recall we actually used this one when we went into our server as well. So essentially, Linode is copying this key for us. And I'll just go ahead and call this, my dev or my dev laptop. Let's call it that. Okay. And so you could also say someone on your team's laptop, and you can get that same key from them, so they would have access to this as well. As you see, we can add more keys. So let's scroll down. As of now, I'm not going to worry about a VLAN or any of these add-ons. Perhaps a private IP would be good in the long run, but for now, we're going to leave it out. Okay, let's go ahead and create this, and I'm going to let it finish creating, and then we'll SSH in. All right, so if we've done it correctly, we could be able to use this command right here. And let's go into VS Code, and I'll SSH here. So root, as it says in there, we hit enter. And it's going to ask me this. This is very common, of course. We're going to go ahead and say yes. So it's permanently added to known hosts. If you're ever curious as to where that location is, what known hosts you have, if you actually go into your SSH, so list out SSH again, and then you can just cat SSH/known hosts or type, you can actually see all of the hosts that are known on this machine, if you weren't already aware of that. But as we see here, we are now SSH'd in, and notice I never had to use this root password here. In fact, even if I do sudo apt get update -y, I shouldn't have to enter that password in either. So this is yet another vulnerability that may or may not be good, right? So on one hand, it's really nice that I can add in my SSH keys when I'm creating any given server, right? That is pretty cool, or any given Linode. But one of the challenges then is this access. So if I lose this machine that I have and somehow somebody knows that I have access to this IP address, they could just SSH in. So one of the ways to solve this is by creating a Bastion server, which is basically a middleman server between me and all of my other services. That's not something we're going to cover at this point. But for now, we have our server and it is provisioned and we are able to log in, which is great. All right, so now we're going to go ahead and configure our PostgreSQL server. So let's go ahead and SSH into our server again, and we'll do a couple installations. So sudo apt update -y just to update our system. This is very, very common to do when you log in to install something new, of course. And then we'll go ahead and do sudo apt install, and it's going to be PostgreSQL, PostgreSQL-contrib, and net-tools-y. Okay, so the net tools is a command that will be useful to see if Postgres is binding to our IP address correctly, or really just to the server as we need it to. So other servers will be able to connect to it. It's just a quick and easy way to verify that with simply netstat-at. Cool. And so what we see is SSH works as expected, right? So it's actually allowing me to SSH because of, that IP address right there. Cool. So now what we need to do is verify Postgres SQL is running. So sudo service Postgres SQL or Postgres and status. That's not one. So you do SQL then, status, all right? Sometimes you might also just say, oh, what if it's PSQL? Same thing. Okay, so it's very common to just try all three of those things, I think. But anyways, so Postgres SQL as the service is active, right? It's running. That's good. Okay, so now what I want to do is I actually want to go into that Postgres SQL. So if I do PSQL, hit enter, I get, or PS rather, that is the command to actually go into the Postgres database to actually run Postgres commands then, or SQL commands. And so what we want to do here is we want to ensure that whatever user I'm using actually has its own database. Now this is optional. You don't have to do this part, but it is nice to see. So if I cd into temp or the temp directory and then do sudo-u Postgres, then we can go ahead and create user and then do $user and then sudo-u Postgres and create DB for the user. And of course, if you echo that user command, you'll see it's root. It's the same user that we're logged in as. But now that we did that, if I do PSQL this time, and now actually lets me in, if I list everything out, I see that there is another database called Postgres, which is for the Postgres user. And so if I do /q, this will quit out of that session. And now what we can do is jump into the Postgres user like this. And now we can actually create our application user and database, right? So the application user is meaning inside of the database, inside of Postgres, we're going to create a user specifically for our application. And then we're also going to create a database for our application as well as a password. Okay, so now what I'll do is inside of this folder here, I'm going to go ahead and do Postgres SQL server. And inside of here, I'm going to make a reference file. This is really for you than it is for me. But the idea here is, first off, we want to declare app.db. And this is going to be, what is our database name going to be? In this case, I'll just call it fast. And then app.db user, I'll call this fast user. And then app.db and password. Let's make sure that these are all caps. Okay. So we want to actually create a password here. Now, there's a lot of ways to do this, but we want a secure password, or as secure as we can make. So I'm going to use the package called OpenSSL, which should already be on your Linux. Then we do rand-base 64, and I'll do 32. Okay. So this password is fairly secure, but one of the challenges is there's a slash in here. We don't want slashes, which I'll explain when we get there. This one should be fine. So I'll go ahead and use this. Okay. I'm actually going to get rid of the equals at the end and maybe get rid of these pluses and put them in as dashes. Okay. Cool. Now, we have these username, password, and database name. So the question is, how do I actually create a database? Well, there are commands to do this, and I'll write out the commands first, and it's first off, create database, and then the name of the database. So in this case, I'll go ahead and just say app.db. Okay, so this command right here is what you would use inside of Postgres SQL, except for this part. You would actually have to hard code that one in. So to make it that I can use these environment variables in conjunction with the actual Postgres commands, what I can do is use the command line version, which is psql --command, and set that equal to some sort of string here. Inside of this string, I can actually use the command for create database. Now, this is a simple and easy way to automate this process, which is why I want to use it. So this is actually the command I'll use. The next one would be create the user. And that, of course, is going to be now this variable. And then we'll say with, you can use caps with password, and then pass in the password one. Okay, cool. And then we can also do something else called grant all privileges, which is yet another command that we will end up using. So grant all privileges on the database, and that's going to be, appdb to appdb user. Okay, so each one of these commands are SQL commands. There are a few more permissions and roles, or really roles related things for a user that I'll just copy and paste. By all means, look these up, but the general idea is I'm setting my user to UTC. Okay, so these are commands that will end up creating a database and a user's password. Now, all of that is working towards something else, which is my actual connection string, or how a client like my app server will actually be able to connect to this actual Postgres database. So to do that, we would use psql ATX, the Postgres SQL // and then I'll give you the format first. So that's going to be our DB user : DB password at, then our IP address or our host name, and then / our, database itself. Okay, so that's the format that we'll kind of keep as a reference for later. And this is just one single way to do that same command of when we are in here is to just do psql, right? But of course, it's for that user and for that database. Okay, so going back in here, let's just fill these things in. And of course, this is going to be my fast user, and then my password itself. And then, of course, or this should be fast user, not fast. And then the database back here is the database. And then the IP address is going to be the one that our actual database server is on, which is this right here. Of course, that's likely to change depending on your system. In fact, your system will not have the same one and likely not have the same password. So the reason we used this kind of password or use those dashes is so that it is ready to be a URL string like this. Now, this is not necessarily the most secure way to access Postgres, but it is a way that we are going to implement because it's a really low-hanging fruit to do so. Okay, so now we have the basis for this. Let's go ahead and actually create that database with all of these commands. So first and foremost, let's go ahead and add in our environment variables here. And I get this bash command not working for this particular user. So let me just ICY. This equals needs to be no spaces. So bring that in, and there we go. And we can verify all these with just an echo command. So appdb user and an echo, appdb password. There we go. Okay, cool. So I just want to make sure that those exist before I actually run the commands. So the first command, it created the database. It gives me that successful response. Second one, created the user with that password. Okay, so in this case, it actually did not let me use that command. And that's because of how the password is set. So what I want to do is change this to have a single quote around it. Otherwise, it's not a valid string for SQL. And there we go. So now I was able to create it, and we come in. Now that actually should be fairly obvious because of these others right here, because all I'm doing with this is string substitution. So whatever this string is would come back in here. Okay. So we set it to UTF, we changed the default transaction, isolation, and then the time zone. and then finally giving all privileges to this user. Great. So now we have that database. Let's go ahead and quit out of here. Oh, I don't need to quit out of there. I can just exit out of the Postgres user itself. And we will continue along here in just a moment. But before I do, I'm going to open up a new SSH session. And what I want to do now is jump into my other Debian US West. I want to jump into my app server to see if that connection string will actually work. So let's SSH in there. Now, if you remember back, we actually required the root user on that one to have a password. The other user that we created did not, but that does not have root access. So let's grab that password we made for reference. There it is. Now, hopefully you didn't lose that one, but if you did, I think you can always reset it on the Linode console. But now that we're in here, what I'm going to do is I'm going to actually install a PostgreSQL client. So this actual server has PostgreSQL. If I hit enter, this happens, right? And so that's fine if yours has that. It's also fine if yours does not, because what we actually want to do is do sudo apt, update, right? So we always want to update it before we install something. And then we're going to go ahead and run the command for the PostgreSQL client. So let me clear this and do sudo apt install PostgreSQL-client. Okay, so that's really all we need here. We don't need all of Postgres installed on this particular server. We just need the client itself, so I can actually call this command right here. Okay, so let's go ahead and call it, hit enter, and right off the bat, it gives me connection refused. Okay, so looking back at netstat, so netstat and then -at, we see that it's not bound like SSH. So we need to bind it like SSH. We need to actually change the default Postgres configuration, which is something we'll do in just a moment. All right, so I'm now in my Postgres database server, and we left it off where if we do netstat-at and hit enter, we see that our PostgreSQL service is attached to localhost. We want it attached to 0.0.0.0.0. This, of course, will bind it to the IP address so we can access it much like we can with SSH. Now, before I even go any further with that, I want to actually implement a firewall to only allow SSH and only allow Postgres, the default for Postgres. So we'll go ahead and do sudo apt install UFW and say yes. And there's two things that I need to allow here, and that's sudo UFW allow SSH. That's the first one because I have an SSH session right now. And then sudo UFW allow 5432/TCP. So 5432 is the port that Postgres uses by default. And then we'll go ahead and do sudo UFW enable. This, of course, could disrupt your SSH, so make sure you allowed it. If you didn't, you will get disconnected. Okay, so now let's just do sudo UFW status and numbered. And there we go. Okay, great. So what we are going to work towards is limiting the access to the 5432 to just our IP address from our application server. We're not going to do that yet, but we will. Okay, cool. So now what we need to do is update the configuration for Postgres to do a couple things. First off, we need it to listen to all addresses, and then we also need to configure it to be bound to 0.0.0. Okay, so those are the two primary things that we need to do now. And these files are just going to be what we need to find. So the first one is the postgres.sql conf. Now, one of the ways to do this is to do find/-name and then that string, and it will find it for us. Typically speaking, we're going to be using this one right here, not the one that says temp files. So let's go ahead and jump in there and say sudo nano. Now this is the standard Postgres configuration file, something that we can change whenever we want to. And so let's go ahead and go page down a couple times and look for the connections and authentication. So the listen addresses, in this case, what we could do is we could have multiple IP addresses that will allow for connection. Now, I just added in a firewall, so we could also use that in conjunction with this. So I'm actually going to be using the firewall, and that's why I'm going to listen to all addresses. Now, this is definitely potentially a huge security risk, right? So you're opening this up to allowing any IP address to access this. Now, this might be good for our local development environment as well, as we can actually then use this database server whenever we need, and especially if you use that in conjunction with the firewall, which we'll see in a moment. The other part is this port right here. This is the standard PostgreSQL port, which is why we just used it in the firewall. And so by all means, change what that port is if you are so inclined. Okay, so I'm going to go ahead and save this with Control X, Y, and Enter. And I'm going to clear this out. And next, we are going to go ahead and update how it is bound to our system. So that is inside of the PG_HBA configuration file. So again, we'll use find/-name, that file itself, and here it is. Now, the reason I'm showing you find has everything to do with the fact that, well, you might change this over time. So we're going to go ahead and sudo in here, or rather sudo nano into here. And we want to go to the very bottom. And so we see the host data here. So we've got our host here. It's going to 127.0.1/32. I'm just going to augment these a little bit and say host, and then all, and then all, and then we're going to go ahead and do 0.0.0.0/0. And then we'll do MD5. I'm going to do something very similar, but this time for the other kind, IPv6. And then this time it's :/0. And again, MD5. We'll save it with Control X, Y, and then Enter. Great. So now I've made some changes. Let's go ahead and restart our service here. So sudo service PostgreSQL and restart. Hit Enter. And this should absolutely restart everything. So now we can do netstat-at, hit Enter. And now we see that PostgreSQL has access to, well, it's bound to the IP address now. So with that, we can actually test our connection to PostgreSQL. But before I do, I'll do sudo ufw status numbered. And I just want to keep this up for a moment for that port. Okay, so let's go ahead and open this up. And let's SSH into our other, Debian West. Let's SSH into that. Okay, and then I need to grab the password. In my case, it's in this file here. All right, so now I'm in there and I want to test the connection itself. And we had that in our reference. Let's see, it's right here. Let's go ahead and copy that, paste it in. Hey, what do you know? I'm able to now connect to it. Now, granted, if you had PostgreSQL on your local machine, you could connect to it as well. I do have Postgres on my local machine, so I can connect to it. Of course, if you didn't, that's okay because, well, we just showed you the test on how this can do it. Okay, so now I just want to remove the firewall for these. Like, I don't want to allow those in at all. So we'll use sudo ufw delete and then the numbers that they exist at. So I'll go say yes at 4, number them again, and then up and delete 2. And we'll say yes again. And let's go ahead and look at them. Now it's only allowing SSH. So let's go ahead and quit out of this session. Now I'm on my app server again. I'm going to try and connect and it hangs. It actually fails. It will not allow me to connect to it, which this is happening, of course, because of that firewall. So yet another reason to implement firewalls, at least a very simple one like this. So we can make the firewall more advanced, right? We do not have to make it specifically anyone can access port 5432. So I'm going to go and do Control C here to close out that command. Now I'm going to add in a new firewall item, and this is going to be sudo ufw allow from, let's go ahead and grab the IP address where I want to allow the connection from, and then to any port 5432 and then the protocol, which is just proto. Let me just open this up a bit, and TCP. So having a TCP connection, we hit enter, rule added. Now we look at the numbered status. Now it's allowing that protocol to come in. So let's go ahead and try and connect with it. Again, I hit enter. This time it does work. And if I list out all of the items in here, I should see data that's related to the database and all of that, which is great. This is awesome. This is actually showing me that that's working. Now, of course, finally, what I can do is then jump back on my local machine. Again, you don't have to do this, but jump back on my local machine to see if I can even access it again. And the answer is, of course, going to be no. And that's, of course, because of that firewall. So like I mentioned before, there are configuration items that you can do with Postgres itself, and you can actually change it to where it's being more specific about these IP addresses. But if we use the firewall, then I can add other IP addresses in the future just with the firewall, not necessarily have to change everything related to Postgres. Now, I'm not a security expert by any means, but I would say that this is at least a more secure manner than just letting anyone access 5432, because that's also a very, very common Postgres port. That is the default. So a lot of people leave it as that. So one other layer of security would be to change that port as well to something just a little bit more robust, just a little different, a little bit open. And so then your connection string would change a little bit. But like I said earlier, we're going to leave it like this so it's nice and easy for me in accessing this data from my app server. Let's continue our horizontal scaling by adding in our Redis data store server. So we're going to go ahead and create a Linode here, and we're going to use that same region that we've been using. We'll use a Linode, and then we'll go ahead and call this Redis server -1, and then we'll add in some tags like Redis and maybe that freelance job thing. We'll go ahead and create a password here. In this case, I'm just going to go ahead and use one I've already used because I'm probably not going to have this server running realistically in production with that password in the future. Anyway, so now we've got these SSH keys as usual. I'll go ahead and create this Linode now. And it's going to take a moment to provision. While it does, I'll just copy this SSH key here. And so also while it's doing that, what is it that we're trying to do here? One, we're going to install Redis. Two, we're going to go ahead and update Redis configuration, basically to bind to 0.0.0. And perhaps we'll also add in a password. So since we're going to add in a password, let's go ahead and generate it now while Redis or that server is still being provisioned, since we kind of know what we're trying to do. Here is a password with OpenSSL. So we'll go ahead and just use that password. Now, unlike Postgres SQL, I don't need to change slashes or pluses. I didn't even need to change pluses with Postgres. I'm just going to leave it like this, and I'll show you how to authenticate once we get there. So that's really the main key here. Now I'm going to go ahead and just check out, see if my server has been provisioned. It looks like it has. So we'll go ahead and say yes and log in. So to configure it, it's actually not going to be that challenging to do. But first, of course, we have to install it. So since we just added this in, we'll go ahead and do sudo apt update and yes. And let that run for a moment. And then we will do sudo apt install redis-server and -y. Okay. Simple enough. Redis-server. Okay. So now in Redis, it actually has sudo nano, and we can do etc redis and redis.conf. So that's typically where that is. It's almost always going to be there. But notice that you can actually call a different configuration on your Redis server too, if you were so interested. I'm not going to change which configuration I'm going to call. I'm just going to change the single one configuration. And so just like we did with Postgres, we can also find this by just grabbing redis.conf and do find/-name and then the name of the file, and we can run that and it'd give us that exact same thing. So you don't have to remember these sorts of things per se, but just knowing that it's redis.conf. Okay, so let's go back in here and nano this out. And it's going to be, well, pretty easy to do because we already have seen it with Postgres. It's not going to be a whole lot different. We just need to find what we're trying to do. First off, this binding here, we can get rid of everything and just do 0.0.0.0, 4 zeros. Okay, Next, we want to change the protected mode from yes to no. Simple enough. Now we'll go ahead and do page down a couple times, and in supervised, we want to change this one to the option of system D, which is right here. Okay. And now we're going to go ahead and go down and look for our password setting, which is require pass. And I think this is actually pretty far down, and it is commented out. Oops, I just passed it. Okay. So it's under security, and here it is. Okay. So I'm going to go ahead and get rid of that. By default, it is foobarred, which is not what you want to use. Instead, you want to use that string we just came up with. And yours should be unique to this, but even if you use this as well, it's okay for testing purposes. I'm not sure how many of you are going to want to pause and run this. So I'm going to go ahead and save this now with Control X, Y, and then Enter. That should save my configuration. So what I want to do is run sudo and systemctl. We want to reload the daemon. Now, this isn't always required when you change the Redis configuration, but it is something you might want to do from time to time. Next, we're going to go ahead and restart redis.service, systemctl restart redis.service, and then we'll just go ahead and grab the status for it. And there's the status. Now, you also might use sudo service and redis and status, and that would give you the same status. Notice that it is bound to this. So one other thing that we can test now is netstat. So let's just try netstat. I might have to install it, but if I just write out netstat, it looks like it's already installed. So perhaps Redis installed it for me. And we can see that it is bound to the 6379 port. This is the default port. So it's yet another thing that we would probably want to change in production, right? And we can find that inside of that configuration file. You can change it right there. And so I do recommend that you do change this in production, but to add some security features beyond changing the port, we can, add in our actual firewall, the UFW. But before we do the firewall, I want to actually test out this Redis connection right now with that password. So let's go ahead and jump into our client, which is going to be, of course, our app server. I'm going to copy this SSHN. And then again, we have to use that password. So let's go ahead and grab that password. Okay. So now this client needs a actual way to connect to this. So to do that, we would do sudo apt get install Redis tools. Now, I probably should have ran update, but in this case, it's fine. We can just go ahead and stick with this. And now that I have this, I can actually run redis-cli, and this will attempt to connect to the local hosted version of Redis. So if I were to install Redis locally, that's what would happen. It would just try to look for that. But of course, I don't want to use the local one, so I'll use redis-cli and -h, and now the host. Now, of course, the host itself is going to be the IP address of our Redis server 1. So we'll go ahead and copy that, hit enter, and now I can actually connect with Redis. So going back into our host here, the Redis server, we're going to go ahead and do Redis and CLI, and I'll go ahead and set a key value pair. So I'll go ahead and set hello to the value of world and hit enter. Okay, so notice it says authentication required. So that actually means that even on my local server, I actually have to add in this authentication key when I'm trying to connect to it, which adds that security. So all I do is type out auth and then that key, and now I can actually set hello world. And then on the other side, I have to do that same thing, and then I can get, that key, whatever that key might be. So that's what Redis is really good about, is key value pairs. And so this actual same command I can use inside of my local machine because I do have Redis installed in here. And so I can connect to it there as well. And yet again, using this password with just simply auth and that password there. And what do you know? So again, I can get hello and it would actually grab that. I can also set ABC being, 1, 2, 3 or something like that. And then on my actual other Redis instances, I can get ABC and get ABC, right? So it's really cool. It's really fast. It's a really easy thing to do. All right, so what I want to do is exit out of my client. I don't really need to worry about that anymore. I certainly can test the connection again if I need to, but now what I need to do is sudo apt install, and we're going to do UFW and then say yes. Okay, so naturally we're going to actually implement our firewall. So the only thing that can access this Redis instance is our app client. So let's go ahead and do that with, first off, sudo UFW allow SSH. We certainly want that. Sudo UFW. And we could do allow 6379 TCP. This is allowing all connections, of course, and that's not what we want. Instead, we want it from the specific IP address of our app server. Paste that in here to any port, and now 6379 or whatever port you changed it to, and the protocol being TCP. We hit enter. Of course, it's updated. So now we'll go ahead and do sudo UFW and enable. And of course, we want to say yes, unless you didn't allow the SSH connection. And then sudo UFW and status and numbered. Cool. So we now see that the actual item for our firewall is now limited specifically to our client host. So that's really it for the configuration of Redis, right? So you can definitely test out if you can even access these things anymore, right? So I shouldn't be able to even access this. It should just hang and then eventually time out because of that firewall. Whereas the client itself should be able to at least go in, but then of course you will have to authenticate with it, which I think is a great thing. But there is a good chance that you might not have to or want to authenticate every single time. So to do that, of course, we go back into our server and then we just go all the way down to wherever that password was again. And the required pass, I just passed it. Comment that out, save this. And then yet again, we would just restart our system. So we can press up a few times to find that one where we can reload the daemon, right? And then restart Redis just like that. And now at the very least, the client will have unfeathered access. So if I do Redis-CLI, I should be able to get, well, the key, if it's still there. It might have went away, but the idea, so like if you did key ABC or ABCD, it might be nil, which is fine, but as long as you don't have an authentication error anymore, that's cool too. So, you know, this is yet another reason that potentially even this server itself is open up to a vulnerability, and that is anyone can SSH in. So perhaps we would want it to being our own server itself, like this, or our own development server, or our own development environment. Or what is very common is to do a Bastion server where it's essentially a virtual machine very much like this, where that one has a firewall to my local computer or my set of computers or even my local network. And then I just go into that and then I SSH into all of these other services. But that's kind of out of the context of what we're doing here. It's just something to be aware of for potential security flaws and holes. So a firewall is not the only thing that can protect us. Of course, there's several layers. But at this point, we now have a Redis server up. We have a Postgres database server. So we've done a lot of really good stuff. So let me know if you have any questions. Otherwise, let's keep going.